students, let us begin with the next content of the chapter Gravitation. In the previous lecture we have learned about the gravitational potential energy. So it is nothing but a stored form of energy attained by the object when it is moving freely under the effect of Earth's gravitational pull. Okay, so whenever an object is there above the Earth's surface, it will get pulled out by the Earth's gravitational pull. So due to this attractive force, the object will get displaced by a certain distance. Now, to displace the object, some amount of work will be done on the object, and that work will be stored in the form of potential energy. And we have seen its formula as well, that is derivation related with what? Gravitational potential energy. When the object is brought from infinite distance, very large distance for a particular point, what is the potential energy being possessed by the object? Now we'll move on to the next content. So today we are going to study what gravitational potential means what. So gravitational potential is again nothing but the gravitational potential energy. But here, instead of considering a single mass, we are finding out what is the amount of work done to move a unit mass. Okay, so to move that mass, how much amount of work we are doing? Okay, at a particular point, the energy possessed by the object is called as it's a gravitational potential. So the gravitational potential, it is denoted by the symbol V, and it is equal to work done divided by mass. So if the object has mass m, that is small m, we know the formula for work done, and it is nothing but the gravitational potential energy. So this is equal to minus gmm upon r. So this is the work done divided by m, or into 1 divided by m, mass of the earth. If I do this m will be cancelled out. So you are getting the formula for gravitational potential as V is equal to minus gm upon r. So see that again we are getting a negative factor, indicate that the gravitational potential energy value will decrease as we go below the surface, means towards the surface of the earth. Okay, so V is equal to minus gm upon r. It doesn't depend upon mass of the object at that particular point. Means what is the mass of the object at a particular point is not matter when we calculate the potential, gravitational potential of a given mass at a particular point. So its SI unit is, since it is work done upon mass, work is being measured in terms of joules, joules divided by kg. So joule per kg will be the SI unit for gravitational potential. And we can write the formula for gravitational potential energy in terms of gravitational potential. We know that the gravitational potential U is equal to work done. Okay, so when I replace this here, V will be equal to gravitational potential energy divided by mass. Okay, or the gravitational potential energy U will be equal to the gravitational potential V into mass m. So the formula for gravitational potential energy in terms of gravitational potential is U is equal to V into m. M is mass of that particular object at that particular point. Now we will move on to the next content, that is known as escape velocity. So what is meant by escape velocity? So that we will see here. We know that object which is there on the surface of the earth, when it is thrown upward with certain velocity, its velocity will slowly decreases. So if this is your earth, r is radius of the earth, m is mass of the earth. So when I throw object upward, it will go above the surface of the earth, and as it goes upward, velocity of the object decreases by a factor of how much? Acceleration due to gravity magnitude, that is 9.8 meter per second. So the value of V decreases as it goes above, and at certain point V will become 0. That is the velocity of the object attained will become 0, and after that the object will start falling down. Okay. So the object basically falls down mainly due to its mass, and the second factor is Nothing but it's a gravitational pull. That is, it is under the effect of Earth's gravitational pull. Therefore, the object will be pulled towards the center of the Earth, and therefore, instead of moving above and above the Earth's surface, the object after certain distance it will again return back. So in the next case, what we will do, we will increase this velocity with which the object is being thrown upward. So at the beginning, if it is just 10 kilometer per hour, we will increase it further. We will make it 100. So if I make it 100, again the object will move, and in this case, since the initial velocity is more, okay, the object may reach some other height, and again when it reaches that height, its velocity will become zero. And therefore again the particle will get attracted towards the Earth's surface, means it will fall down. So what I will do here, the effect which has been seen, that is falling of the object towards the Earth, it is basically due to the Earth's gravitational pull. Okay, so when the object is there above the surface of the Earth, it will experience a force, and due to that force, the object will get attracted towards the center. Means the object is getting accelerated. Now, as the object moves upward, the acceleration value will change by a factor of how much? 9.8 meter per second. Now, assume that we have thrown the object with very high velocity, so that the object is reaching very small height. It will reach very larger distance, and at that particular distance, the value for acceleration will become zero. Means the gravitational pull on the given object is zero. Is the point clear? So it is a point wherein the gravitational pull is zero. Means it is not there under the effect of the gravitational pull. Then what is the velocity with which the object is being thrown? That is called as the escape velocity. Again, there is a big difference between it. If I throw the object with a speed of 100 meter per second, the object will attain a height such that the gravitational pull is zero. If I throw it with again a height of 2000, again same, it will go above the Earth's gravitational pull. Now, which velocity you need to consider? To consider the minimum velocity with which the object is supposed to be sent above the surface, so that there is zero gravitational pull which is acting on the given object. So here it is the minimum speed which is required, means sufficient speed which is applied on the given object, so that it will move vertically upward and will never returns back. Why it never returns back? Because the gravitational force acting on the object at that particular point will become zero. So when it is not being applied by any attractive force, it won't return back home, isn't it? It will remain at that particular point. Okay, so it is the minimum speed, with which when the object is thrown above the surface of the Earth, it won't return back only. Means it will go just out of the Earth's gravitational. And that minimum speed with which we need to throw the object from the surface of the Earth is called as what? Escape velocity. It is called as escape velocity. So see that we have used the term minimum. If the energy or the velocity is more than that, it will go out of the Earth's gravitational pull, and remaining energy will be used to move again in the space. So we don't want that extra energy. We want the enough energy or sufficient energy so that it will just come out of the Earth's gravitational pull. Okay. So therefore I have to use the minimum speed which is required to move the object out of the Earth's gravitational pull, and that speed is called as what? Escape speed. Now we will see the formula for it, escape speed. So to find the formula, we will relate the total energy content value. So what is total energy? It is basically related with two factors. One is the kinetic energy when the object is moving, then the potential energy when the object is at rest position. The The energy possessed by the objects at these two different conditions, its sum is called as what? Total energy. Okay. So total energy of the object when the object is lying on the surface of the earth is equivalent to kinetic energy plus potential energy. So when the object is lying exactly on the surface, we will throw the object with certain velocity. Therefore, the object will have maximum velocity or in turn maximum kinetic energy when it is there on the surface. Okay. So when the object is thrown above the surface, what will happen? Whatever kinetic energy was there, okay, will be slowly getting converted into potential. Why? Because it is another effect of acceleration due to gravity, and as the object moves above and above, the velocity value will decrease by a factor of much? 9.8 meter per second. So therefore, the kinetic energy will also decreases. And as the kinetic energy decreases, whatever energy is there when the object is moving will be now converted into the gravitational potential energy. And when the object reaches certain height wherein V is equivalent to 0, it indicates that the total kinetic energy of the object is 0. So at that point, it is found that whatever kinetic energy was there inside the object have now totally got converted into potential energy. Okay, so potential energy at maximum height will be having maximum reading, whereas kinetic energy on the surface will have maximum value. Now, if I want to make the object move away from the earth's surface, the total energy factor which is of the object should be either a positive quantity and or it should be equal to 0. It should be equal to what? 0. Means the two energies should be equal to each other. That is, magnitude of the kinetic energy on the surface is equal to the gravitational potential energy at that particular height. When these two factors will be equating each other, it is found that the total energy of the object is equivalent to 0. Okay, so we will just find out what is the total energy of the object when it is lying on the surface of the earth. So total energy is equal to kinetic energy plus potential energy. Kinetic energy is half of mv square. So I just denote the velocity here, it is v of e. Okay, so half of mv square plus, this is the formula for gravitational potential energy, that is minus gm upon r. So this r I have chosen because it is lying at some distance r, capital R, that is radius of the earth from the center. So this is the distance at which the object is lying from the center of the earth, and that is nothing but radius of the earth. So I have chosen here minus gm upon r. So this small r will be replaced by the radius of the earth, that is capital R. Therefore, the formula for total energy will be equal to half of mv square plus minus gmm upon r. Okay. Now, to come out of the Earth's gravitational pull or Earth's gravitational attraction, what I have told, the total energy of the object which is there should be either a positive quantity, okay, or it should be equal to 0. Okay. When these two conditions satisfies, it is found that the pull which is acting on the object will be equivalent to 0. Okay. So therefore, the total energy will be either greater than or equal to 0. So total energy here on the surface we have half of mv square minus gmm upon r, which is greater than or equal to 0. So this is an inequality sign. So to simplify this, what you have to do? You have to add minus gm upon r. Add gmm upon r on both sides of the equation. So when I add it, this term will get cancelled out on this side and extra term will appear here. Therefore, the equation will become half of mv square is greater than or equal to gmm upon r. Or if I want to simplify this further, multiply both sides by 2. So when I multiply by 2, this 2 will get cancelled out. mv square will be equal to 2gmm upon r. Again, divide on both sides by m and this will get cancelled out. So when I simplify the inequality equation, we are familiar to solve the inequality equation. Solve it here in a similar manner. So we are getting what? VE square is greater than or equal to 2gm upon r. Okay? Or when I remove the root square here, apply the root on this side. So VE will be greater than or equal to root of 2gm upon r. So this is the initial speed. It may be anything. But to come out of the Earth's core, what velocity we need to apply is nothing but the escape velocity. So that should be the minimum value. To escape the Earth's surface, we have to have minimum escape speed. Therefore, I will replace this V of E by V minimum. So V minimum is equal to root of 2gm upon r. And this V minimum is nothing but the escape velocity of the object. So therefore, the formula for escape velocity is equal to VE is equal to root of 2gm upon r. Okay. So G is equal to, we have one more form of it, that is acceleration due to gravity can be written in terms of gravitational constant G as gm upon r square. So from this we have gm upon r is equal to g into 1r, you take it to this side. So the equation will become root of 2 gm upon r can be replaced by g into r. Therefore, the value for escape velocity or the minimum speed which is being thrown is equal to root of 2gr. So see that in this equation as well as in this equation, we do not have mass factor, means mass of the object is not there. Okay, as well as we do not have any angular factor. So what does it indicate? It indicates that the escape velocity of object, it doesn't depend upon what is the mass value, means how much weight the object has, whether it is 10 kg, whether it is 100 kg, what is the mass of the object, it doesn't matter. So therefore the escape velocity is independent of two factors, one is mass of the object and the other is direction of projection, means what is the angle with which we have thrown the object, whether it is been thrown straight, whether it is moved this way, whether it is thrown this way, how it has been thrown above that particular point, it doesn't matter. Okay, so it doesn't depend upon mass of the object, it doesn't depend upon angle of projection. Okay, so this is the formula for escape velocity, means it is the minimum velocity with which the object has to be thrown when we want the object to come out of the Earth's gravitational pull, or the gravitational force which is acting on the object at that particular height, if it has to be equivalent to 0, we need to throw the object with certain speed, that is called as escape velocity. And see that escape velocity depends upon two more factors, one is mass of Earth and the other is radius of the Earth. Means if the Earth structure changes, if mass of the Earth becomes larger or if it becomes smaller, radius if it is less or if it is greater, then also the value for escape velocity will change. So for Earth, if you want to throw the object above the Earth's surface, if I substitute everything here, I am getting the value as 11.2 km per second. Means if with that velocity, if I throw the object above the Earth's surface, it will go out of Earth's gravitational pull. The point clear? Then one more factor is why your moon doesn't have any atmosphere. So it is basically due to its radius or its actual size. So mass of the moon, radius of the moon is very small. Okay, therefore the value for your escape velocity in that case, it is found to be equivalent to 2.3 km per second. Means if any particle which is there on the surface, if it moves with that much of speed, okay, or just above that speed, that is 2.3 km per second, then automatically it will go out of pull of that particular object. Means if the object on the surface of the moon has a speed equal to or greater than 2.3 km per second, then it won't retain on the surface of the moon only. Therefore, the moon doesn't have any atmosphere. Okay, so the value for escape velocity in other bigger planets will be larger. Okay, because size of, we have different planets which is larger or bigger than the Earth's surface. If you go with the Jupiter, it is very high because that the mass as well as radius of that particular planet is higher. Therefore, if you want to remove that object from the pull of that particular planet, you need to apply very large energy, or the escape velocity of the object should be very high. Okay, so this was about escape speed. Then we move on to satellites. So what are meant by satellites? These are the bodies or objects which will be revolving around the planets. Okay, so those objects which are moving around a planet are called as satellites. So you have two main categories in it. One is known as natural satellite. Natural is naturally occurred during the evolution of your Earth or your solar system. So that type of object is called as a natural satellite. So Earth, we have a moon is a natural satellite which has a duration of 23 point something 7 days of rotation. Means the time of rotation around the Earth of that given satellite, that is the moon, it is 27.3 days. So it will take that much of days to complete one complete rotation around the Earth. Okay, so that is a type of satellite, that is natural one. Then it's artificial. Artificial or nothing but the man-made. Means with the technologies to satisfy certain demands, to do research works for telecommunication purposes, what they have done, they have sent certain satellites which are man-made above the surface of the Earth, and these satellites will be revolving continuously around the Earth, sending the required information. So since these are the heavenly bodies which are revolving around the Earth's surface, they are also termed as satellites, but they are given a name, that is artificial satellite. Okay. So at the beginning, Russia, okay, in the year 4th October 1957, they sent their first satellite Sputnik 1, okay, around the Earth orbit. India, almost 20 years later, that is in 75, they sent their Aryabhatta satellite. Again, not from the India launching pads, they have used Russian pads to launch their satellite. Okay. So now we have our own, the recently Chandrayaan, Moon Abhiyan, those have made a tremendous contribution in the field of research and technology, and we are still in urge of sending a satellite to means out of the Earth's surface to different planets. We are finding different solar systems, whether they are present with the help of these type of satellites or man-made bodies. Okay, so these are called as naturally occurring. These are the man-made satellites. Is the point clear? So satellite definition you are familiar. It is nothing a body which is revolving around in a particular orbit around a given planet. Different planets, they have different amount of satellites that is naturally occurring. Okay. So this completes the content, that is escape velocity and satellites. Further information related to the satellite we will see further.